Hello, my dear viewers. In this session, I am planning to answer a university question which is comparatively lengthy, coming in PERT analysis. I selected this because of its magnitude. Nearly 7 or 8 questions are there. It is selected from university question paper for MBA IF, International Finance Students of Calicut University, June 2018. Okay, let us discuss steps of these problems one by one. A problem from the university question paper of University of Calicut for MBA in International Finance of June 2018 is going to discuss. This is a question from PERT analysis, activity and time, TO, optimistic time, most likely time, pessimistic time. It's a problem of network analysis belonging to program evaluation review technique. It's a problem of probabilistic nature. This is the data. And the questions are: draw project network and identify all paths, determine expected project length, calculate standard deviation and variance of the project length. What is the probability that the project will be completed at least 4 weeks earlier than the expected time, not more than 4 weeks later than the expected time? And if the project due date is 19 weeks, what is the probability of not meeting due date? What is the probability that the project will be completed within 20 weeks? And finally, find the project duration at 90% probability. This is a problem from PERT. It is belonging to part D in university question paper, fetching 24 marks. This question is little bit lengthy. Question 1, 2, 3, 4. 4 are belonging to normal distribution and 3 are belonging to our usual critical path, project duration, etc. This is a problem from PERT analysis, program evaluation review technique. This is a PERT problem we are going to answer. The first we have to understand is that it's a PERT problem, program evaluation review technique. It has 3 different time elements for a project. That is optimistic time, that is the smallest time, average time, most likely, and pessimistic time. There are 3 time elements. The first step of answering is calculating of the most expected time. Using the 3 values, we calculate the expected time TE. Its formula is optimistic time plus 4 times most likely time plus pessimistic time divided by 6. We have to compute this formula or this time estimate for each activity. For example, the first one. For the first activity, T is equal to optimistic time 1, 4 times most likely time, 4 into 1, plus 7 by 6, that is 1 plus 4 plus 7 by 6, that is 12 by 6 equal to 2. In this fashion, we calculate expected time for each activity. And this next step is, this is probabilistic. Therefore, we have to calculate variance for each activity. We have to calculate variance, and variance is equal to, variance is optimistic time, variance for each activity, variance is pessimistic time minus optimistic time divided by 6, the whole square for each activity. and variance of critical path. Variance of critical path. Variance of critical path is equal to sum of the variances of critical activities. Sum of variances of critical activities. So at the first step, we are calculating expected time and variance for each activity. We are moving to answering the problem. First step, calculate expected time and variance for each activity. Using this formula, we calculate the expected time as and variance as, that is 1 plus 4 plus 7, 12 by 6, 2, etc. We calculate using this formula for each activity the expected time and variance 7 minus 1 for the first case, 7 minus 1 by 6 whole square, 6 by 6 whole square, 1 square equal to 1. That is for each activity we calculate variance, and for each activity we calculate the expected time. That's a PERT problem. This is a PERT problem. It has 3 different time estimates for an activity: optimistic, most likely, pessimistic. For the computation of critical path, we need only one time, that is the average time. Using these 3 time estimates, we calculate the average time, or TE. Its formula is T0 plus 4Tm plus TP by 6. And we also need the variance for each activity. Since it is probabilistic, the formula is TP by TO by 6 whole square, where TP is the largest value pessimistic time, M is the middle most likely average time, and TO is the optimistic time. Its rate is 147, for example. 1 smallest, more than 1 4, more than 4 7. Pessimistic is the largest, optimistic is the smallest. The computation is exhibited on the board. The TE values are 2, 4, 3, 1, 6, 5, 7. Variances are 1, 1, 1, 0, 4, 1, 4 for each activity. Using these 2 informations, we calculate the average time or the critical path and variance of the critical path. Now the information is edited. Event 1, event 2, activity 1 to 2, expected time and variance. Using this data, we are preparing for drawing network diagram. Network diagram is drawing the first activity 1 to 2, node, arrow for activity 1 to 2, 1 to 3, arrow, node, 1 to 3, 1 to 4, 1 to 4, then 2 to 5 and 3 to 5, 2 to 5, 5 is a converging point, 5, 4 to 6 and 5 to 6. This information, event 1 to event 2, 1 to 2, 1 to 3, 1 to 4, that is activity. So this is the network diagram. That is comparatively a simple diagram, a brief diagram, and the information are 1 to 2, 2, 1 to 3, 4, 1 to 4, 3, 2 to 5, 1, 3 to 5, 6, 4 to 6, 5, 5 to 6, 7. So the diagram is complete. The first question is answered. Then listing all activities, all paths. What are the paths? 1 to 2, 2 to 5, 5 to 6, 1, 2, 5, 6. The duration is 2 plus 1, 3, 3 plus 7, 10. The other path is 1, 3, 5, 6. The duration is 4 plus 6, 10. 10 plus 7, 17. And 1, 4, 5, 3, 5, 8. That is, we have 3 paths. Then which is the critical one? Listing all the paths and select that path which gives the largest value. That is the minimum time required for the completion of the project. This is the critical path, that is 1 to 3, 3 to 5, 5 to 6, 1 to 3, 3 to 5, 5 to 6, and the duration is 17. In the information, the data is given in weeks. So the duration is 17 weeks. Critical path is the longest one. Here we can compute critical path by forward backward computation. 1 to 2. 2 is the node. Forward computation 2. 1 to 3. Forward computation is 4. 1 to 4, that is 3. 3 to 5, 2 to 5. There are 2 possibilities, either from 3 to 5 or from 2 to 5. We consider the largest value. 2 plus 1, 3. 4 plus 1, 6, 10. We take 10. 10 plus 7, 17. Here, 3. 3 plus 5, 8. 10 plus 7, 17. We use the maximum. That is a forward computation. Then we are calculating the backward computation. Starting from 17. 17 minus 10. 7. 10. 17 minus 7, 10. 17 minus 5, 12. 10 minus 6, 4. 10 minus 1, 9. Here, 2 minus 2, 4 minus 4, 3 minus 3. We take the minimum, and forward computation also 0. These are the forward and backward computation. And we consider the difference between forward and backward as 0. 0, 0, 0, 0. Therefore, the critical path is 1 to 3, 1 to 3, 3 to 5, 5 to 6. The critical path is 1 to 3, 3 to 5, 5 to 6, and the duration is 17. So we determine critical path by 2 methods. For the examination purpose, only one method is necessary. I illustrated both procedures for considering critical path. Therefore, the critical path is 1 to 3, 3 to 5, 5 to 6, and the duration is 4 plus 6 plus 7, 17. Since the unit is weeks, it is 17 weeks. This is the ordinary question in all PERT CPM question, determine critical path. Then here it is one more in PERT. Calculate the variance. Since it is a probabilistic problem, the variance of the critical path is necessary. The variance of the critical path is sum of the variances of critical activities, where variance is TP minus TO by 6 whole square. So, variance of critical path 1 to 3, it is 1. So, it is 1 plus the other path is 3 to 5, it is 4. 1 plus 4. The third one is 5 to 6, its variance is 4. Therefore, the total is 1 plus 4, 5 plus 4, 9. The variance is 9 weeks. The variance of the critical path is 9 weeks. And one more question. Standard deviation. Standard deviation of critical path. Standard deviation. It is from quantitative techniques. What is standard deviation? It is square root of variance. Square root of variance equal to root of 9. That is 3. We are entering to the next phase of the problem. We determined the critical path, that is 1 to 3, 3 to 5, 5 to 7, and the time duration is 17 weeks. Variance is 9. Standard deviation is 3. Then we have to answer questions of this type. Probability of completing the project 4 weeks earlier than the expected time, not more than 4 weeks later, and the duration is more than 19. duration is less than 20, and probability is 0.9. Here we use normal distribution. So the students have to refer normal distribution. For answering these questions, we introduce a normal variable x. X be the duration of the project. And the expected duration is 17. We know that for normal distribution, there are two parameters. One is the mean, the average duration. It is 17 weeks. Weeks is the unit given in the problem. And the second parameter is variance. Variance is 9 or standard deviation 3. So we introduce a random variable x, which denotes the duration of the project. The average duration is 17 weeks and standard deviation is 3 weeks, which are the two parameters of the normal distribution. Then the standard normal denoted by z is equal to x minus mu by sigma. That is x minus 17 by 3. Mu is 17, sigma is 3, which follows a standard normal distribution. Then all the questions are answered with respect to the normal distribution. For normal distribution, we use the property of standard normal distribution, and to determine probability, we use standard normal probability tables. For that, refer normal distribution. Then now we are going to find the probabilities of 1 and for each questions. The next segment of questions is related to finding probability. Find probability that the project will be completed 4 weeks earlier. 4 weeks earlier than the expected time. Expected time is 17. Standard deviation is 3. So the required probability is 4 weeks earlier. 17 minus 4, 13. Probability of x less than 13. That's the required probability. And we use the property of standard normal distribution, where z is x minus 17 by 3, which follows standard normal. Therefore, the required probability is probability of x less than 13. That is, probability of z is less than 13 minus 17 by 3. That is, z is less than minus 1.33. Then using the area of standard normal curve. This is the standard normal curve. Here, mu is 17. The correspondingly, z is 0. 17 minus 17 by 3, 0. And the required probability is z is minus 1.33. The area to the left of. This is the required probability of completing the project before 13 weeks. And referring to standard normal table, we get area up to 1.33. That area is 0.4082 from tables. 0.4082. Therefore, the required probability is, this entire probability is 0.5 to the left of. So, this is equal to 0.5 minus 0.4082. That is equal to 0.0918. This is the required answer. That is, the probability of completing the project before 13 weeks is 9% or 0.0918. Refers normal distribution for the subject know-how. Then find the probability that the project will be completed not more than 4 weeks later than the expected time. The expected time is 17 weeks. Standard deviation is 3. Therefore, not more than 4 weeks later. 17 plus 4, 21. Not more than 21 weeks. That is, x is less than 21. Therefore, the required probability is probability that x is less than 21. That is the statistical problem. We know that z is equal to x minus 17 by 3 follows standard normal distribution. So, in the same fashion, the required probability is x is less than 21. That is, z is less than 21 minus 17 by 3. That is probability that z is less than 1.33. Then we go for the standard normal curve. Z is 0, mu is 17 here. The required probability is x is 21. The corresponding Z is 1.33. So the required probability is area to the left of 21. The shaded push area to the left of 21. From tables, we get area from 0 to 1.33. Using standard normal tables, we get area from 0 to 1.33 as 0.4082. And this portion is less than the mean, less than mu, less than 0. It is 0.5. Therefore, the required area is this area plus this area. That is 0.5 plus 0.4082. That is 0.9082. Therefore, or that is the required probability of completing the job before 21 weeks is 0.9082 or 90.82%. Same type of question. The wording is find the probability of not meeting due date. Not meeting if due date is 19 weeks. That is theoretical question. We have to convert it into statistical terminology. That is probability of x is more than 19. Not meeting due date. It takes more than 19 weeks. That is Z is greater than 19 minus 7 by 3. That is Z is more than 6.7. Then we go for the standard normal curve. Mu is 17. That x is 17 here. X is 19 here. The area is more than 19 to the right of 19. That is right of Z is 0.67. That is probability of Z is more than 67. That is to the right of entire area. This area to the right of 0 is 0.5. Probability of 0 less than Z less than infinity minus this portion, this area. That is 0 less than Z less than 0.67. That is 0.5. The area to the right of 0, 0.5 minus 0.2486 from tables. This is from tables for an area up to 0.67 from standard normal tables. So this area is 0.2514. Therefore, the probability of not meeting the due date if it is 19 weeks is 0.2514 or 25.14%. Here the question is to find the probability of completing the project within 20 weeks. That is 20 or less. The time should be 20 weeks or less for completing the project. That is probability of x is less than 20. That is a normal with the mean 17 and standard deviation 3. We standardize it. That is probability of Z is less than 20 minus 17 by 3. Z is less than 1. Then we go for the normal table. This is a normal table. Here mu is 17 and correspondingly Z is 0. 17 minus 17 0. X is 20. 17 and 20 is to the right of 17. Correspondingly Z is 1. We require the probability of Z is less than 1. That is this area. Probability of minus infinity to 0. Minus infinity to 0. Probability of minus infinity less than Z less than 0. Minus infinity plus probability of 0 less than Z less than 1. That is 0.5 plus 0.3413. This is 0.8413. This is from standard normal tables. 0.3413 is from standard normal tables. Therefore, the required probability is 0.8413. It is the probability of completing the project before 20 weeks. That is, its probability is 84.13%. Then discussing the last part of the question. Find the project duration at 90% probability. This is a problem of reverse order. The probability is given. Find x. The earlier problems are for finding probability. So this is a problem of reverse order. It is given that probability that x is less than x dash is 0.9. X dash, that's a notation. You may use x1 or something like that. X dash is 0.9. That is given. Then it is converted into Z, into standard normal. X is less than x dash is equal to 0.9. That is Z is less than Z dash is equal to same 0.9. At where Z is x minus 17 by 3. At x dash, it is z dash. That is x dash minus 17 by 3. But then most important problem is the location of x dash. Then we go for the standard normal curve. Here it is x equal to 17. Z is 0. Area to the left of 17 is 50%, 0.5. We want an area 0.9. Therefore, we move to the right by 0.4. Then area is 0.5 plus 0.4, 0.9. Correspondingly, the position of x dash is there. Then x dash, at x dash, z dash is equal to x dash minus 17 by 3. So this is z dash. So first our problem is to locate z dash using standard normal table. From tables determine z for an area 0.4 from 0 to z. This area, find this z dash. That is, using tables, we cannot locate exact area 0.4. Using standard normal tables, I am using 0.3997. The next value is 0.4015. So I am preferring this value. We get z dash is 1.29. Z dash is equal to 1.29. That is, z dash is 1.29. At x dash is x dash minus 17 by 3. That is z dash is equal to 1.29. Now it is a simple equation. Solve for x dash. X dash is equal to 3 into 1.29 plus 17 equal to 3.87 plus 17. That is 20.87. Approximately 21. We use weeks as the unit. So it is 21 weeks. Therefore, probability that x less than some date is 0.9. That is 21 weeks. This is the answer to the problem. Find the project duration. Project duration is 21 weeks. This is a problem of reverse order. We are using tables in the reverse pattern. A comparatively lengthy question is completed now. This question is common to business administration PG students, commerce students, or any students coming under post-graduation level in operations, research, or management science. Usually, such a lengthy questions are not coming in a question paper of postgraduate studies, but it is a lengthy one. I selected because of that reason. It is a lengthy question. So we discussed all area related to program evaluation review technique. I hope that you are satisfied with this solution. My humble request is go for the properties of normal distribution and standard normal distributions. Okay, for time being, we meet again with another university question paper. Thanks a lot.